Hello students, I am Subhashish. Previously, you have learned about the surface area and volume of a cuboid. Today, in this part, we are going to see the surface area and volume of a right circular cylinder. Look at the objects around you, cups, cans and even some containers. Do you notice something common among them? They all have a shape that's a bit like a rolled up piece of paper. The shape is called a cylinder. Imagine a straw or pencil, those are cylinders too. So, whether you are sipping a drink or drawing a picture, cylinders are there, quietly playing a part in our world. They are simple yet super useful shapes that makes things work. There are many types of cylinders. Let's focus on right circular cylinder in this lesson. Learning outcomes. After the completion of this lesson, you will be able to understand cylinder and its characteristics, the curved surface area of a cylinder, the total surface area of a cylinder, the volume of a cylinder. Keywords from this lesson are height, radius, curved surface area, total surface area, volume, cylinder. Now we will learn what is cylinder and its characteristics. A cylinder is a three-dimensional geometric shape that resembles a tube or a soda can. It is a circular figure with two parallel circular bases connected by a curved lateral surface. Characteristics of a cylinder. A cylinder consists of two circular bases that are equal in size and shape and lie in parallel planes. These bases are at the top and bottom of the cylinder. The lateral surface of a cylinder is a curved surface that wraps around the sides connecting the two circular bases. It is like the curved surface of a tube or a can. Now we will understand the curved surface area of the cylinder. The lateral surface area of the cylinder refers to the curved surface that wraps around the sides of the cylinder, excluding the top and bottom circular bases. Here, height of the cylinder is h and the circumference of the cylinder is 2 pi r. When we unwrap the curved surface of the cylinder, it looks like a rectangular sheet, where the height of the cylinder resembles the breadth and the circumference of the cylinder resembles the length of the rectangular sheet respectively. Now, the curved surface area of the cylinder is equal to area of the rectangular sheet, that is equal to length into breadth, that is equal to 2 pi r into h. That is equal to 2 pi r h. where r is the radius of the cylinder, h is equal to height of the cylinder. Now we will solve a problem. For his project, Umesh had to construct a model of a cylindrical kaleidoscope. He wanted to construct the kaleidoscope curved surface by using chart paper. What size of a sheet of chart paper would he need to create a kaleidoscope with a 35 cm length and 4.2 cm radius? Solution. In this question, they have asked to find the lateral curved surface area of the cylindrical kaleidoscope. Given length of the cylinder is equal to 35 cm, radius of the cylinder is equal to 4.2 cm. We know that the curved surface area of the cylinder is equal to 2 pi RH. Now substitute the values in the formula. We get 2 into 22 by 7 into 4.2 into 35, where pi is equal to 22 by 7. By multiplying, we get 44 into 0.6 into 35, which is equal to 26.4 into 35. By multiplying, we get 924 cm square. Hence, the required area of chart paper is equal to 924 cm square. Now, we will understand the total surface area of the cylinder. The total surface area of the cylinder is the sum of the curved surface of the cylinder, top and bottom circle bases. We know that the curved surface area of a cylinder is a rectangular sheet. So, the total surface area of the cylinder is equal to area of top circle base plus area of bottom circle base plus area of rectangular sheet. That is equal to pi r square plus pi r square plus 2 pi r h. Two pi r square plus 2 pi r h. Now take 2 pi r's common, then we get 2 pi r into r plus h. Now we will solve a problem. A closed cylindrical tank of height 140 centimeter and a radius of the base is 56 centimeter is made up of a thick metal sheet. How much metal sheet is required? Solution. In this question, they have mentioned that it is a closed cylindrical tank. So, we should consider the total surface area of the cylinder. Given height of the cylindrical tank is equal to 140 cm, radius of the cylindrical tank is equal to 56 cm. We know that the total surface area of the cylinder is equal to 2 pi r into r plus h. Now substitute the values in the formula. We get 2 into 22 by 7 into 56 into 56 plus 140. That is equal to 2 into 22 into 8 into 196. By multiplying, we get 44 into 1568, which is equal to 68,992 centimeter square. Hence, the area of the metal sheet required is equal to 68,992 centimeter square. Students, let us understand the volume of a cylinder. The volume of a cylinder refers to the amount of space or capacity inside the shape. It measures how much a cylinder can hold. It's like measuring how much water, toys or any other material can fit within the cylindrical wall. Or volume is nothing but the total space occupied by an object. The formula for calculating the volume of a cylinder is equal to area of circle into height, which is equal to pi r square into h. Now we will solve a problem. Find the mass of the concrete required to build a cylindrical pillar of height 14 meter and radius 1 meter. Solution. In this question, they have asked to find the mass of the concrete and they have given the density of the concrete. Now first, find the volume of the cylindrical pillar. Then after, using the relation between density, volume and mass, we can find the mass of the concrete. Given height of the cylinder is equal to 14 meter, radius of the cylinder is equal to 1 meter, density of the concrete is equal to 2400 kg per meter cube. We know that the volume of the cylinder is equal to pi r square h. Now substitute the values in the formula. We get 22 by 7 into 1 square into 14. Which is equal to 22 into 2. By multiplying, we get 44 meter cube. Therefore, the volume of the cylindrical pillar is equal to 44 meter cube. Now, we will find the mass of the concrete required by using the relation density is equal to mass by volume. Density of the concrete is equal to 2400 kg per meter cube. Volume of the cylindrical pillar is equal to 44 meter cube. We know both the density and volume of the concrete. Substitute the values in relation. We get mass is equal to density into volume, which is equal to 2400 kg per meter cube into 44 meter cube. Mass is equal to 1,05,600 kg. Hence, the mass of the concrete required to build the pillar is equal to 1,05,600 kg. Students, let us summarize what we have learned. Points to remember. A cylinder is a three-dimensional geometric shape that resembles a tube or soda can. It is a circular figure with two parallel circular bases connected by a curved lateral surface. The lateral surface area of the cylinder refers to the curved surface that wraps around the sides of the cylinder, excluding the top and bottom circle bases. The curved surface area of a cylinder is equal to 2 pi r h. The total surface area of the cylinder is the sum of the curved surface of the cylinder, top and bottom circle bases. The total surface area of a cylinder is equal to 2 pi r into r plus h. The volume of a cylinder refers to the amount of space or capacity inside the shape. The volume of a cylinder is equal to pi r square h. Thanks for watching.